Hello everyone, welcome to Artistic Atom channel. I'm Fatima and today we will be covering our topic materials and their structure. This is the continuation of our previous session. This is our session 6 and I will be covering subtopic 2.6. Now, the learning objectives for this particular session are as follows. Firstly, we will be understanding different properties of elements and compounds. Nextly, we will be understanding how compounds are named. Lastly, we will be understanding the particle diagrams. And finally, we will be ending our session with the understanding of chemical formula. Now our topic is properties of elements and compounds. When we talk about elements, we know that elements are nothing but a huge structure formed by the atoms of the same kind. And when we talk about compounds, they are nothing but the structures which are formed out of different atoms bonding together. So these different atoms, when they bond together, they result in the formation of what compounds. Now, since in case of elements there are same kind of atoms, they have their unique properties. Whereas in case of compounds, when these elements they combine together and they form a compound. So when these elements they combine together and form a compound, they lose their original properties and they get the new properties, whatever that compound may have. Now, the conclusion is different elements have different properties. Why? Because each element consists of same kind of atoms. So whatever are the atoms, that will be the property of that particular element. So if I have two different elements, they both will be having different properties. When we talk about compounds, compounds will get different completely new properties because the original elements they lose their properties after combination. Now let us take an example and understand. When I talk about sodium element, it has properties as follows. Firstly, it is very soft, shiny metal, whereas chlorine element has poisonous yellow color green gas. Okay, but when we combine them to form a compound, so I'm combining sodium element with chlorine element, it results in the formation of sodium chloride compound. Since it is formed of two different atoms, we call it as what? Compound. And when we talk about the properties of sodium chloride, they're completely different because it is no more a gas, no more a solid shiny metal. It has converted into a common table salt, and common table salt is safe to eat, but neither sodium or chlorine is safe to eat in their elemental form. So this means when these elements they combine and form a compound, they completely lose their original properties and get their new properties after the combination. Now, the next topic is naming compounds. So, whenever we talk about compound consists of two parts. The first part of the compound is the metal one, and second part of the compound is the non-metal one. So, whenever we write the name of the compound, always the metal name comes first. So, we always write the name of the metal first. Now, the name of the non-metal always been written second, and whenever we write the name of the non-metal it always changes. Okay, let us take an example and understand this. When I combine sodium and chlorine, it results in the formation of sodium chloride compound. So when we are writing the name of that particular compound, we do not write sodium chlorine. What we write sodium chloride. So here the name of the metal is written same as it is, whereas the name of the non-metal changes. This is what I was talking about over here. Now, how to decide whether which name which subscript to be sorry which suffix to be selected for writing non-metals name? Well, there is no such rule given, but still this is what we have got till now, that if you have three elements combined together and one of them should be oxygen, then always you will end the name of that particular non-metal with the these letters ATE. Okay, so like for example, if I have calcium, plus carbon plus oxygen. So calcium plus carbon plus oxygen. Here I have three elements combining together and one of them is oxygen. So I will write the name of the metal first. So which one is the metal? Metal is the calcium. So I will write calcium and then carbon and oxygen combines and I will end their name as what? ATE. So I will write it as what? Carbonate. Hope it makes sense to you. Now, nextly, most of the time you will find that the non-metal's name is ending with IDE. That is ide. So, like for example, here we have written sodium. Instead of writing chlorine, we have written it as what? Chloride. So, this is how actually we name the compounds. We always write the name of the metal first, followed by the name of the non-metal. Depending upon the condition, we are going to use the suffix in the name of that particular non-metal compound. Now, the next that we will be learning is what actually is the function of this name, like what we get exactly from the name. So when we name a compound, we get the idea of the atoms that it contains. Like for example, if I'm writing carbon dioxide, from the name itself I get to know that there is carbon, and since I am writing dioxide, so oxide means oxygen. When I'm using this prefix, it means di means two. This means the compound contains one carbon atom and two oxygen atom. This is what the information we get after writing the name of the compound. So if you just read the name of the compound, you will get to know the different elements present in that particular compound. Another example is carbon monoxide. So carbon means carbon atom, mono means one, and oxide means oxygen atom. So I know that in case of carbon monoxide, there is one carbon atom and one oxygen atom. So this is what the information we get after writing the names of the compound. So this is why it is important to understand how to write a name of the compounds, because if you know the rules, then you will be able to make out the number of atoms from the given name of the compound. Now, next is the particle diagram. So, particle diagram is this. As you can see in the picture, this is how actually we make the particle diagram, where we use spheres to represent the atoms. So, these particle diagrams, they actually helps us in understanding which atoms are present in the given structure. Like for example, if I talk about carbon dioxide, I can see this is the particle diagram for carbon dioxide. I can see that there is this gray colored carbon atom and these two are red colored oxygen atom. So from this color code only I can make out that these two atoms are same, whereas this one is different. This means this particular structure is what? A compound, because I can see that it is formed out of different atoms. Here also in case of water, I can see in particle diagram that these two H are of same colored sphere. This means they are same atoms, whereas this one is the different atom. This means this is also an example of compound. If I talk about this one, I can see that there are same spheres with the same colors used. So I know that this one is nothing but an element, because it is made out of same elements, okay, same atoms, okay. So in last one, this is the structure for methane, or the particle diagram for methane, where I have one carbon atom and four hydrogen atoms. Since they are different, carbon atom is different and hydrogens are together, so I can say that it is made up of two different kind of atom. One is hydrogen and another one is carbon. So I will conclude that this is also a compound. So always remember, when in a substance you have same kind of atoms bonded together, you will call them as what? Elements. And when you have a substance with a different kind of atoms bonded together, you will call them as what? Compound. And what is the function of particle diagram? It tells you which atoms are present in the given substance. Now, nextly, we will be understanding how to write a formula. Okay, so formula tells you how many atoms are present. Like, for example, here I'm talking about calcium oxide. So, this formula, this chemical formula, will tell you how many atoms of each elements are present in the given substance. And always remember, there is a subscript number that we write after the symbol of that particular element, and that number tells you the number of atoms of that particular element present in the given substance. Suppose if there is no number, like for example, in this case, I cannot see that any number written after the symbol of calcium or oxygen. So I will consider it as if there is no number written, this means there is only one atom of that particular element is present in the given substance. So let us understand what information we get from this particular formula, or how to take out the information about this particular substance from its formula. So when I see calcium oxide, first step is to identify the elements present. So I can see that Ca is the symbol, chemical symbol for calcium, and O is the chemical symbol for oxygen. So I have determined which elements are there in the chemical formula. Now the next step is to check for the subscript, whether subscript is given or not. So I can see that there is no number written after calcium or oxygen. So I will consider that since there is no number, this means there is one written. Okay. So I will consider that there is one atom. So now lastly, write down the number of atoms of each element present in the given formula. So as I can see, calcium has no number. This means there is one calcium atom. And since oxygen also has no number, this means there is one oxygen atom. So in conclusion, what is the meaning that I'm getting out of this particular chemical formula? It tells me that there is a one calcium atom which is bonded to one oxygen atom to form calcium oxide. So this is how actually we take out the information out of the chemical formulas given. So with this, we have completed our session. Hope you have understood everything. Do like, share and subscribe to my channel Artistic Atom. See you in the next session.